If your query is slow because of a sort, let's look at when an index can help and when it can't. Hi, I'm Jakub from DB Booster Academy. Order by, and this is really important, is the only way to guarantee the output order of rows in SQL. Without it, the result order is undefined, effectively random, even if it looks good when you run the query. If you need a specific order, you must use order by. When the data cannot be retrieved in the required order, or when the execution plan contains steps that do not preserve order, the optimizer introduces a sort operation. Sorting is performed in memory, but if the available memory is insufficient, the sort will spill to disk, which adds extra cost. A sort can take significant time regardless of whether it spills or not. However, significance depends on context. If your query runs for 5 minutes and sorting represents only, let's say, 10 seconds, removing it may not be meaningful for your tuning goals. Working on sort removal is a good idea only when it supports your performance goals. Let's start with a simple example. I want to select ID, name, score, and revenue, and order the result by score descending and revenue ascending. To make this query fast, I created an index with the following columns: score descending, revenue, ID, and name. I added ID and name so the index is covering. ID and name could also be placed in the include section of the index if the engine supports it, because they are not used in filtering, ordering, so their order in the index does not matter for this one particular query. This table represents the leaf level of the index. Score is sorted from the highest value, and rows with the same score are ordered by revenue, and so on. The execution plan for this query uses only an index scan. There is no sort operation because the index order already matches the order by. So this index is the perfect one for this query. If I switch score descending and revenue in my index, the execution plan will require a sort operation. Even though the index is covering and contains the right columns, the order of the key parts does not match the order by clause. Because the index is ordered first by revenue, the database cannot return the rows in the required order directly and must sort the result. If I keep the correct column order but remove descending, the execution plan will again require a sort operation. This time the issue is the sort direction. The index is ordered by score ascending, but the query requires score descending. So the index order cannot be used directly. The database must sort the result to produce the correct order. If I place only score descending in the key part of the index and move other columns to include, then revenue is no longer sorted. The index is still covering, but the database must perform a sort. The last index I want to show is score descending and revenue ascending. This index has the correct ordering, but it is not covering. In this case, it's likely cheaper to do a full scan and sort than to use the index and perform a table lookup for every single row. Let's do a small recap. To avoid a sort operation, the index must already contain the rows in the required order. To avoid a sort, the index must contain the same columns as the order by in the same sequence, and the sort direction must be compatible. If the order by is all ascending or all descending, the index can use either direction. The database can simply scan the index forward or backward. But if the order by mixes ascending and descending, then the index must match the sort direction exactly, as we saw in the examples. If any of these are violated, the database cannot use the index order and must sort the result. Included columns are not sorted. Now we add some conditions, starting with equality. So far, we focused only on ordering. Now let's see how equality conditions and order by work together. I kept the query the same and added an equality filter on name equals King Kong. There are 9 matches. With our previous index on score descending, revenue, ID, and name. The leaf pages are ordered by score and revenue. Since name is the last key, the database can't use it to narrow the search space. It scans all rows and just filters by name. The execution plan is an index scan without a sort, but the scan reads more than 10,000 rows to return 9. As you remember from the episode about equality conditions, equality preserves the ordering of the next index key. So we can move the name to the beginning of the index. This allows the database to dive directly into the first King Kong and then read the others, while still returning the rows ordered by score descending and revenue. The execution plan changes to an index range scan, reading only 9 rows with no sort operation at all. Next, we replace the equality condition with an inequality condition. I want movies with a budget lower than $10 million. We have 2 options. Start from the order by and then filter, or start from the inequality and then sort. Let's examine both scenarios in detail to avoid any doubts. An index orders a column only within the rows that share the same value in the previous column. Here, the score is the previous column, so the revenue is ordered only within each score group. However, as revenue values are different, budget is not ordered globally, so we cannot use it to narrow the search space. The database cannot use budget as an access predicate, it can only use it to filter rows during the scan. So the database will perform an index scan. It reads all rows in the correct score revenue order and applies the budget condition as a filter. When we start with budget and then follow with the order by columns, score descending and revenue, the score values are not sorted across different budget values. For example, here at the end of the rows with a budget of 1 million, the score is 0. But when the budget increases to 1,100,000, the score jumps to 89, 71, and so on. So the result set is not ordered according to the order by clause. The database can perform an index range scan to read all rows with a budget low enough, but it must sort the result afterward. When we combining where conditions with order by, the structure of the index matters a lot. Equality conditions are easy, they come first. Equality filters narrow the search space and the next index key is still sorted. That means that the database can continue to use the index ordering to satisfy the order by clause. However, inequality does not work that way. An equality condition produces a range, and that range may contain many different values of the next key. Because of that, the ordering of the next index column is no longer guaranteed across the entire result. So when we have an inequality condition, we must make a choice. We can start the index with the inequality column and then sort the result afterwards, or we can start with the order by, get the rows in the correct order, and then filter using the inequality condition. There is no universal solution. The right choice depends on your data distribution, selectivity, and performance goals. The last case in this episode is order by with limit. When we add a limit, the situation changes. We no longer need to get all rows, we only need the top n rows in the required order. Let's say I want to select ID, name, score, revenue, and order the result by score descending, revenue ascending, and get only the first 10 rows. I have covering index with leading columns following the order by. Because the index already matches the order by clause, the database can simply read the first n rows from the index and stop. No full scan, no sort, extremely efficient. Without a supporting index, the database has to retrieve all rows that match the filters, sort all of them, and only then apply the limit. The key difference for single table queries with limit is that limit acts like a filter, so the right index can dramatically reduce the amount of work, because the database can stop as soon as it has enough rows. It's time for the summary. To avoid a sort, your index must contain the same columns as the order by clause in the same sequence and with the same sort direction, ascending or descending. These columns should be placed at the beginning of the index or immediately after any equality conditions. Inequality conditions are harder. With an inequality, you have to choose whether to optimize for the order by or for the inequality filter. You generally cannot optimize both at once. Limit increases the importance of indexing for the order by because it allows the database to stop early when the rows are already ordered correctly. This episode focused on order by and indexes on a single table. Joins will change everything. And we'll go through the different cases in depth in the next video, just as we did here. I know these videos are longer than what you may be used to, but I truly believe that understanding the principles is far more valuable than memorizing patterns. It's the only reliable way to become truly confident and truly professional with data. Don't forget to like and subscribe. Take care and see you next time.